In section 1, we worked on writing equations in slope-intercept form. Now we're going to talk about writing equations in standard form and point-slope form. And we've done standard form some before, but we're going to do a little more with it again. And really in this lesson we're also going to talk about how all three of them relate to each other. So the standard form, as you may recall, takes on the form ax plus by equals c. A, b, and c are numbers. A and b are coefficients of x and y. C is a constant. And this isn't all the rules, but the main rules you need to think about is no fractions for a, b, and c. And a can't be negative. It's fine for the y term to be negative, it's fine for the c to be negative, but this term cannot stay negative. Now, the new one, which I think I maybe had you write down, but otherwise it's brand new. It's called the point-slope form. You do y minus y1 equals m times x minus x1. Y and x represent their own, no, I use this differently. The x and the y are variables, just like x and y are variables up here. x1 is an x value from a point, so it's a specific number in a problem. y1 is the y value from that same point, so it's a number in a specific problem. And m is slope, just like it was in the slope-intercept form. So to write this form, you must know two things. The slope, because you need m, and one ordered pair. Any ordered pair on the line, you can plug into x1 and y1, plug in the slope, and then you're done. So first, let's briefly review the standard form. So remember, if you're told to put things in standard form, you're trying to make sure it gets in this direction, this order, and it follows these rules. So right now, y is on the correct side, x is not. So we need to subtract 3x from both sides. And I'm going to put the negative 3x up front because we know we want it to be before the y in order to be in the correct form. So this has everything in the correct order. We have the x, then the y, then the constant. But one of the rules says that this term cannot be negative. It's okay for the other terms to be negative or not, but this one can't be. So to fix that problem, we've got to multiply all three of these terms by negative 1. So negative 3 times negative 1 is positive 3. 2 times negative 1 is negative 2. 4 times negative 1 is negative 4. So as you can see, it essentially just changes the signs of every term so that the x term can become positive. Okay, on this one, both x and the y are on the right side, but they're in the wrong order. So I need to put the negative 5x first, the positive 4y second, and the 10 goes last, which is where it already was, but that's the correct place for it. But we run into the same problem we ran into in number 1. This is all in the correct order, but we can't let a, the coefficient in front of x, be negative. So we need to multiply or divide, either way, everything by negative 1. Multiplying and dividing by negative 1 both have the same result. It changes the signs. So negative 5 over negative 1 is positive 5. Positive 4 over negative 1 is negative 4. And 10 over negative 1 is negative 10. Okay? Now, this one actually has everything in the right order, in the right form already. We have our x term, then our y term equals our constant. But we have fractions, and we can have no fractions for a, b, or c. So there's two ways you can approach this. Since there are two different denominators, one thing you could do is multiply everything by each denominator individually. So I think I'll actually try to show you both ways. So first, if we want to get rid of the 1/2, we can multiply every single term by 2. Okay, so 2 times 1/2 is 1, so we have 1x. 2 times 2 is 4, so we have 4y. Then treat this as 2 over 1, so we have 2 times 3 is 6, 5 times 1 is 5. So we've made it halfway there because we did get rid of the 1/2 in front of the x, but we still have a fraction right here. So we can get rid of this denominator by multiplying every single term by 5. So 5 times 1x is 5x. 5 times 4y is 20y. And then you can cancel these two 5's out, leaving you just the 6. So if that makes good sense to you, that can be a great way to get rid of two different denominators. Multiply by one of the denominators all the way across, then multiply by the other denominator all the way across. But I'm going to rewrite the question and show you a way you can do it in one step if you want to. The whole reason we multiplied by the denominator is so it would cancel it out. So multiplying by 2 canceled out the 2. Multiplying by 5 canceled out the 5. So we can look at this and say, okay, what number would cancel out both of them? In other words, what number goes evenly into both 2 and 5? And that would be 10. So we could also multiply everything by 10. And as you'll see, we get the same result. So here we get 10 on top, 2 on the bottom. 10 divided by 2 is 5. 10 times 2 is 20. And let's see, 10 over 1, 10 times 3 is 30. 1 times 5 is 5. 30 over 5 is equal to 6. So you can choose which way you want to do it, because as you can see, they give us the same correct answer either way. Now time for the point slope form. I think sadly this is an underappreciated form. I know in some advanced math I've taught it's so much better to use point slope form than some others. So we'll see what you think about it. This form is most useful when you have the slope and one ordered pair. So the slope-intercept form is great when you have the slope and the y-intercept. The point-slope form is great when you have the slope and any point on the line, whether or not it's the y-intercept. So let's practice writing things with the point-slope form. So remember, the point-slope form is y minus y1 equals m times x minus x1. Y and x are variables. We never plug things into them. Not when we're doing this anyway. But x1 and y1, those come from right here. So the 8 is my x1 and the 2 is my y1. So I would write y minus 2 equals the slope, which is negative 3/4, times x minus 8. And I'm done. That's one of the cool parts. You can get it very quickly and easily. This is the point slope form. And one reason it's seen as beneficial is just like with the slope intercept form, you could right away look at it and say, oh, here's one point, it's the y-intercept, and here's the slope. Here you can do one thing. It's just the point you know isn't the y-intercept. It's just a random point because it's being subtracted, so that would be the point 8, 2. Slope of negative 3/4. Okay, number 5, we would do y minus the y value, so minus 3, equals m, which is 5, times x minus the x value, which is negative 1. Now, one thing I'd encourage you to do is go ahead when you see minus and negative, just change it to a plus. So I, from now on, because you know minus and negative is the same as plus or positive, I'll just jump straight to the line I'm writing right now instead of writing that first line. So anytime you're subtracting a negative, it turns into plus and positive. And that is our answer. Okay, I'm going to jump to 7 because it's a unique one, and I'll let you do 6 on your own. So a vertical line. A vertical line has no slope, meaning, well, how am I supposed to write an equation if I have no slope? Well, all vertical lines are of the form x equals c. C being whatever value x is always equal to. So if this is a vertical line, and we know it passes through the point negative 5, 4. So 1, 2, 3, 4, 5, and up 1, 2, 3, 4. So we know it hits this point, and it's a vertical line. Well, we know what x is equal to. It tells us right there. So this equation is simply x equals negative 5. Now that's a unique type, the vertical line. It doesn't really look like it's in the form we need, and I understand. But when you have a vertical line, there's really no way around it. A vertical line is always going to be of the form x equals c, and c is whatever value x takes. Now number 6 is a lot more like number 4 and 5, so I encourage you to pause this, try it on your own, then press play when you're ready to see if you got the right answer. So I'll start with y minus negative 5. So minus and negative turns into plus 5 equals the slope, negative 1/2, times x minus the x value, which is 4. Okay, you can do this with graphs as well. This may seem a little harder, but it's really the exact same information we were given on the other one, a point and a slope. So I would do y minus the y value, which is 4, equals the slope, which is 1/2, times x minus the x value, which is 2. So if you feel up for it, you pause and you try number 9 on your own. We do y minus the y value, which is 5, equals the slope, which is 2, times x minus the x value, which is 3. So these can be very quick and easy, whether we're given a point and a slope, or if we're given a graph that are showing a point and a slope. Okay, here's another one. It's not super unique. I don't think it's as difficult as the vertical line, but let's talk about how we do it with the horizontal line. So just like a vertical line has undefined slope or no slope, a horizontal line has a slope equal to 0. So they've actually told us in here exactly what we were given in the previous questions. They've given us a point and they've given us a slope, because a horizontal line has a slope of 0 because it's flat. So we'd say y minus the y value, which is negative 2, minus negative 2 turns to plus 2. Our slope is 0. We do x minus our x value, which is 4. Now this is technically in point and slope form, but in my opinion, leaving it this way doesn't make a lot of sense, because 0 times anything is 0. So this would come down to y plus 2 equals 0. Or if you subtracted the 2 to the other side, it'd be of the form y equals negative 2. And that is more often how you see horizontal lines written, is y equals a number. Which if you look, it matches the number y was in that point. And it always will for horizontal lines. So I will accept this answer. That is in point slope form. I do think this is the best answer though, since horizontal lines are almost always written that way. Well, I saved the real fun for these two problems. Ready or not, here we go. Sometimes they don't give us a slope. Instead, they just give us 2 points. We dealt with this a little in the previous section. And sometimes they may say, here's some information, and we want to know all 3 forms of the line that would fit this information. Whew. It's a lot. They're supposed to say things like, bruh, or seriously, or I don't know what else, but you get the point. One thing I'll tell you though, is when they ask you to do all of them put together, the best thing to do is find the point slope first. Because we know we need the slope, so we'll find that. y2 minus y1 over x2 minus x1. So we get 5 over 1, which is 5. And now that we have a point and a slope, we can pretty quickly write the point slope form. So do y minus, you can do either one of these. I'm going to choose this one, no reason why. Minus the y value equals the slope, x minus the x value. So we've got the point slope form. Now for some of you, you're thinking, wait a minute, this is going to look different if I pick a different point. You're right, it will look different, but it will be equivalent. And on a test or quiz, I'll be ready to know either one that you use what the answer would be. Okay, so to get a slope-intercept form, it's pretty simple. We want y by itself. So step 1 is to distribute the 5 over here and add 7 to both sides. So we get y equals 5x plus 2. Okay, then to get the standard form, we need to get the x back over on this side. So we'll subtract 5x from both sides and put it in front of the y. So we have to have ax plus by equals c. If we do run into one problem, we can't have this be negative. So we've got to multiply everything by -1 so that we don't have a negative a negative coefficient in front of x. So that changes that to a positive 5x, this to a negative y or minus y, and this to a -2. And don't worry, when I give you one like this, I treat it as more than just one question. I know it takes a while. So it'd be cool if you felt brave and pressed pause and tried this one on your own. Feeling brave? Well, you should. Okay, let's imitate the same path. We'll find the slope first. 11 minus -1 over 2 minus -2. So that turns into a plus. 11 plus 1 is 12. 2 plus 2 is 4. So the slope is 3. So I'll use this point this time. I'll do y minus -1 is plus 1 equals the slope times x minus -2, which is plus 2. So we got the point slope form. And the steps from point slope to slope intercept are the same every time. Distribute the slope through on the right side, and then add or subtract this constant to get the y by itself. So we get y equals 3x plus 5. Then, to get the standard form, we'll want to subtract the 3x over to this side. So it's on the correct side, and we'll put it in the correct order. And we run into that negative problem again, so we got to multiply everything by a negative number so that the first term, the a, or the ax, is positive. So -1 times -3 is positive 3. -1 times -y, -1 times y is -y. And 5 times -1 is -5. All right, good news, we're almost there, and these last ones will not be nearly as long as the two we just did. I promise. Okay, this says write each equation in standard form. So if you notice, both of them start in point slope form. So let's start by doing what we almost always do, and that's distribute if we can. So I'll distribute -3 I'm just treating that as negative 3 times negative 1, so that's positive 3. Then I want to add the 3x over to this side. Get 3x plus y plus 2 equals 3. So the x and the y are where they need to be, but I needed all the constants on this side, so I'll subtract 2 from both sides. I fear I went a little bit too fast on that one, so I encourage you to pause and look through that again if you need to, and I'll make sure I go at a better pace on this next one. Again, first thing we want to do is distribute. Do negative 1/3 x. Negative 1/3 times negative 6 is positive 2. Okay, now I want to add the 1/3 x over the left side because that's where it belongs. Also, in the same step, I'm going to go ahead and add 1 to both sides so I can get that out of the way. So I've canceled this out here and this out here. That leaves me with a positive 1/3 x plus y is equal to 3. But this is breaking one of the rules we talked about, and that's the fact we can't have fractions as our a, b, or c. And a is 1/3. So we'll have to multiply everything by its denominator, multiply everything by 3. 3 times 1/3 is 1. 3 times 1y is 3y. And 3 times 3 is 9. Last two. Write each equation in slope-intercept form. So as I mentioned when we drew 11 and 12, the pattern of getting from point slope to slope-intercept is very much the same every time. We'll distribute over here on the right side. So y minus 6 equals 3x minus 1, because 3 times 1/3 is 1. Then we'll add 6 to both sides, so we get the y by itself. Same process. We will distribute on the right side. 1/2 times 2 is 1. Then we will subtract 5/3 from both sides. If it helps you, just remember that 1 is the same thing as 3 over 3. So negative 3 minus 5 is negative 8 over 3. Now you could also write that as 2 2/3, or I think it'd be 2.6 repeating if you use the decimal. Whew, I know it's a lot, a big lesson, but we're trying to make sure we know all three of the forms and how we can convert from one of those forms to another.